So with this video, we will be starting off with the graph series.
Hello, hello. Think we are live, right? We are live, we are live, we are live. So, yeah, let's go to the next algorithm, that is Kruskal's minimum spanning tree algorithm. So, a minimum spanning tree or a minimum weight spanning tree of a weighted, connected, and directed graph is a spanning tree that has minimum weight. The weight of a spanning tree, the sum of all edges in the tree. Minimum weight spanning tree. So, okay, for those who don't know spanning tree, no cycles and connect all vertices. Okay, so for those who don't know what is a spanning tree is, so let's say I have one, I have two, I have three, right? I have this, right? This is structure. Let's say I have 1 to 2 cost me to 5, 2 to 3 cost me 3, 3 to 1 cost me 2. So this is a graph, right? And its equivalent spanning tree, or not equivalent, a minimum spanning tree will be, we can connect 1 to 2, or we can connect 1 to 3, and 3 can be connected to 2, right? So from each node, if we can go to any node, and the weight is weight of the nodes, the sum of weights, right? Sum of weights should be minimum, minimum. So that tree we call minimum spanning tree. So sigma sum of weight I, sorry, weight I, where I is equal to 0 to number of nodes minus 1 is minimum, right? Over over all spanning tree possible. Tree possible, right? Okay. Okay, so that's we understand, right? What is a spanning tree? I think we understand that. So what is, okay, now we will understand what's a Kruskal's algorithm. So in Kruskal's algorithm, we sort all edges of the given graph in increasing order. Okay. Then it keeps on adding new edges and nodes in the MST if the newly added edge does not form a cycle. It picks the minimum weight edge at first and the maximum weight edge at last. Thus, we can say that it makes a locally optimal choice in each step in order to find the optimal solutions. Hence, this is a greedy algorithm. Okay, so Kruskal's algorithm is greedy algorithm. That is that is new thing that I know. Okay, okay, okay. So are we live? Second, are we live? I think we are. Hmm, yeah, yeah, live. Okay, so for those who don't understand this line, let me repeat this line again. In Kruskal's algorithm, we sort all edges of the given graph in increasing order. Hmm. Okay. Then it keeps on adding new edges and nodes in the MST. Mhm. If the newly added edge does not form a cycle, it picks the minimum weighted edge at first and the maximum weighted edge at last. From these lines, I don't understand anything. Let's go to some visualization to make to make us understand this better. Okay. How to find MST using Kruskal's algorithm. Whatever. Kruskal, whatever. Below are the steps for one MST using Kruskal's algorithm. Sort all the edges. How to find MST using Kruskal's algorithm? Sort all the edges in non-decreasing. Give me 2 minutes, guys. ಅದಲ್ಲೇ
आज उल्टा हो गया भाई जनरली मोना ज्वाइन किया था तू बुक चोरी कर क्लास मोना बुक चोरी कर
अच्छा भाई इसी
क्या है
इसी खुशी में मुझे कुछ पार्टी वार्टी दे दे यार। मैंने ज्वाइन कर लिया देख सबसे पहले।
आपने भी देखा भाई मोना ज्वाइन नहीं करता समझ
गाली मार इसको मोना।
क्या साले धंधे
हाँ
1 घंटा नहीं हुआ तेरा
हाँ हाँ मजा आता
क्या कर रहा है भाई ठीक है 10 15 मिनट में आ जाना चुप चुप
sorry guys, there was a call so I got busy.
And the first video in this series will be
Okay.
introduction.
So yeah, there was a call and I got busy there. So let's continue with MST. Let's understand Kruskal's algorithm. So how to find MST using Kruskal's algorithm? That is the question we have in front of us. So below are the steps for finding minimum spanning tree using Kruskal's algorithm, right? Sort all the edges in non-decreasing order of the weight. Let's understand this, right? Let's also draw this and understand this. How to find MST using Kruskal's algorithm. How to find MST using Kruskal's algorithm. Okay, below are the steps. So there are 3 steps mainly. Disjoint and data structure to detect cycles. Oops. Okay. So sort all the edges in non-decreasing order of their weight. So basically increasing, non-decreasing means increasing. Pick the smallest edge. Check if it forms a cycle with the spanning tree formed so far. If the cycle is not formed, include this edge, else discard it. Repeat step 2 until there are v minus 1 edges in the spanning tree. Okay. Kruskal's algorithm uses disjoint set data structure to detect cycle. Hmm. Okay, so like, oh, this is a big graph, so I'll not draw this, right? It will take a lot of time drawing this graph. So let's just understand this by seeing the graph. So the graph contains 9 vertices and 14 edges, right? I'll just create the answer here, right? Okay. So the minimum spanning tree formed will have 8 edges for this graph, right? Okay. So what is the first step? Sort all edges in a non-decreasing order of their weight. So increasing order, right? So minimum weight is between 7 to 6. So 7 comma 6 and the weight is 1, right? Okay. Similarly, next is 6 comma 5 and the weight is 2. 6 comma 5 and the weight is 2. And then we have 2 0 1 and 2 5. Oops, battery is low. Guys, I need to connect to it first. Give me 2 minutes, I'll connect. Laptop, charger. So these are no, charger is connected and we are back. Okay, so we have created 652 and okay, just we will look it here and we'll figure out, right? So the first step is we have to sort them. So we'll do. We have done 1 6 2 5 and 0 1 4. There's no edge with weight 3. So okay, so there is another edge 8 2 with weight 2. Uh, 2 8 with the weight 2. Then we have 0 1 with weight 4. Then we have 0 1 with weight 4. Similarly, we have 2 5 with weight 4. 5 with weight 4. Then we have with weight 7 is minimum, I think. 2 3 with weight 7. 2 3 with weight 7. Then we have uh 7 8 with weight 7. 7 8 with weight 7. Then we have 1 2 with weight 8. 1 2 with weight 8. Then we have 0 7 with weight 8. 0 7 with weight 8. Okay, then we have weight 9. 8 6, I think. Okay, I need to consider 8 6 also. With weight 6, right? 0 7. 8 is done. Then we have 9 3 4 with weight 9. 3 4 with weight 9. Then we have 5 4 with weight 10. Then we have 5 4 with weight 10. Then we have 1 7 with weight 11. 1 7 with weight 11. Right. Then we have 3 5 with weight 14. 3 5 with weight. So we have sorted all the ages by increasing order of their weights, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 ages sorted by weight, right? We have 14 ages. Those are sorted by weight. So what is the next step? Pick the smallest edge. Check if it forms a cycle with the spanning tree formed so far. Okay. If the cycle is not formed, include this edge, else discard it. Repeat the same step until v minus 1 edges in the spanning tree. So currently there is no spanning tree, right? So pick the smallest edge. We can pick 7, 6, 1. Pick 7, connect it to 6, and mark the weight as 1. It doesn't form any cycle, right? Cycle will be like basically if I have another 5 and 6 is connected to 5 and 5 is connected to 7, so it will form cycle. We don't want cycle. We don't want cycle in spanning tree. Repeat the same step. So okay, this is discarded. Next is 6, 5, 2. So 6, 5, and the weight is 2. It doesn't form cycle. Okay. Next is 2, 8, 2. So 2 and 8, the weight is discarded. Next is 0, 1. So 0 and 1, and the weight is 4, right? Discarded. Next is 2, 5. 2 and 5. Does it form cycle? No. Weight is 4. Add it. Discard it. Next is 8, 2, 3, 4 edges are there. 4 more. 8 and 6. So does 8 and 6 form cycle? If it connected, yes, it forms a cycle. So I'll not consider it. The next is 2, 3, 7. 2 and 3. And okay, I can make 3 here. Mark the weight as 7. Okay. Next is 7, 8. 7 and 8. Does it make a cycle? Yes, it is. Not considered. 1, 2. Does it make a cycle? No, we can consider it. 8. Next is 0, 7. 0, 7 doesn't make cycle. Yes, it is. Next is 3, 4. 3 and 4. Okay. 4. Weight is 9. Remove it. 5 and 4. Make a cycle. Yes, it is. Remove. 1 and 7. Make a cycle. Yet it is not considered. 3 and 5. Make a cycle. Yes, it is not considered. So we have 1, 2, 3, 4, 5, 6, 7. We got 1, 2, 3, 4, 5, 6, 7, 8 edges. Right, we have 8 edges, and this is the minimum spanning tree we get. Now the most important step, did you know what is the most important step was? To discard the, now like how, okay, so first of all we have to like prove how will this be the minimum, how can we say this is the minimum. So okay, so since we have picked up the smallest weights, right? We have picked up the smallest weights. So this will by default get us the minimum spanning tree. Like out of all formations that we can create, this will be the minimum because we are picking the minimum weight first. So it's an intuition, mathematical proof. There is a mathematical proof, but I don't think right now we have the time to go into that proof since we need to just understand the algorithm, solve problems, and improve our rating, right? In future, maybe if I have time, if time permits, then we can also deep dive into that. Okay, so first step is clear, right? We have created the MST. But did you notice one thing? Now, like to figure out the uh, how did I figure out that if it is 8 and 6 are form a cycle of knot? So if they are of the same, so I'll just increase this, right? Okay, from Here I don't think so. Let's say, huh. So let's say, so initially they, can you find the pattern that they are like disjoint set data structure? So we can create a disjoint set, right? Initially all are disjoint, right? All are in single set, right? And when we keep on adding elements, so initially all 1 2 3 4 5 6 7 8 are. I think this will be better here. Mm-hmm. So one, I think this is the 1 to 0. Yeah, this is MST. Total cost is 37 and are also 1 2 3 7 11 19 21 28 37, right? So basically what we will be doing to figure out if it contains a cycle or not. So let's say when we were adding 8 and 6, so they were already in the same set, right? Now if we maintain a disjoint set, so these will come into the same set and this will have same common representative, right? Common representative. So from that we can say that representative, and from that we can say that uh, they cannot be included because they have common representative, and it will create a cycle if we try to connect 1 and 7 again. They are already connected, so we cannot connect them again. So okay, so this makes sense, right? I think we understand the Kruskal's algorithm also here, right? That makes sense. Hmm. Okay, then we can solve some problems on that. Number of
Now I
provinces.
use Whisperflow. I just think
Let's say, let's solve one problem. Record, record, wait, what? Record, number of provinces, disjoint set. Hmm, I think this problem already I have solved. I need to log in. I will. Mhm. Okay, so this is already solved. So there are. Should I solve this again? There are some of them. I don't think we need. I think this is so simple. Just the simple disjoint set will solve this problem. So I don't think we need to do this again. Mm, let's solve this problem. Maybe there is this unique problem we can solve. Right. Go to the next. Solve this problem. Okay, this is not solved, so we can solve this problem. Okay. Okay, we'll solve this. So number of operations to make network connected. Okay. Let's solve this problem. This seems to be fairly easy problem as we have already understood Kruskal's and the TSU algorithms. So this will be a fairly easy problem to solve. Number of operations to make network connected. Okay. So there are n computers numbered from 0 to n minus 1. Okay. connect by Ethernet cables, connections, forming a network where connection I represent a connection between computer A, I, and AI. Okay. Any computer can reach any other computer directly through the network. Okay. Okay. You are given an initial computer network connections. You can extract certain cables between two. You can extract certain cables between two directly connected computers and place them between any pair of discrete computers to make them directly connected. Return the minimum number of times you need to do this in order to make all computers connected. If it is not possible, return -1. Okay, so it's saying that you are given an initial computer network, right? And what I can do from that, let me remove the charger. My laptop is getting hotter. See how much battery it is charged. It is charged 53%. Ah, that's good. That's good. Okay. So you are given an initial computer networks. You can extract certain cables between two directly. You can extract means remove certain cables from two directly connected computers and place them between any pair of disconnected computers. So basically, I can remove this cable and I can connect it to this remote desktop, right? Remote desktop, and now they are all connected to a pair. Okay. So I have to return the minimum number of times I need to do this in order to make all computers connected. And if I cannot make them connected, that's it. If I don't have this cable, then I can't connect to this table. Okay. So so what's the condition? So basically, what's the condition that is it possible to connect all computers to each other? So the condition is number of cables should be greater than or equals to the number of uh, should be greater than or equal to the number of computers -1. Okay, so let's refresh this. Condition is number of cables should be greater than equal to number of nodes -1. And yeah, I have to give minimum number of times I need to do this operation. Okay. Hmm. So I have to tell the minimum number of times I have to do this operation. Okay, this is the problem that I need to solve. Hmm. Mhm. Okay, so we have figured out the problem. Okay, okay. We have this class connections. Okay. Mhm. Hmm. So by reading this problem, what is coming into my mind? Hmm. Uh, so by writing DSU, we can figure out the number of disjoint sets. Right? This is disjoint. This. So there are possible one, two, and three sets, right? So if I have the number of disjoint sets with me, and if I know the number of cables is count is 1, 2, 3, 4, 5 is less than equal to number of nodes -1, then I can create MST out of this. If I can create MST minimum spanning tree is what? Connecting each node. I don't need minimum spanning tree. I just need spanning tree. The problem is just can I create a spanning tree or not? And let's say if I have three three disjoint sets. So, and the condition can be satisfied by if the number of connection cables are this. So, the number of disjoint sets minus 1 will be the answer, right? Uh, that makes sense. That makes sense. So it's quite easy. I don't think this is difficult. It's quite easy problem. I think you have understand, right, what I'm thinking, right? Hmm. So just to figure out the number of disjoint sets, answer will be uh, number of disjoint sets. Let's say that is n, right? So answer will be n minus 1, right? That makes sense. That perfectly makes sense. Perfectly makes sense. We need to connect, right? Okay. So this looks an easy problem. So I just copy this. Just copy this. Go to my code screen. And yeah, this is my disjoint. This is my disjoint. This is my solution. Okay. And what will I do? What will I do? Okay, make this down. Boom, boom, boom. So, ages, right? We can figure out the ages first. And ages is equal to connections. Then, okay. And if ages is less than n minus 1, right? Okay, then return minus 1 because then it's not possible, right? Because edges are less than n minus 1, we cannot connect all of them. Otherwise, what we have to do? Otherwise, it's just really, really easy. We just have to. One second, guys. ये आ गया क्या दल्ला
आ गया ना ऑलरेडी
रुक जा यार आ रहा हूँ आया आया भाई आज आज ग्लोबल चैंपियनशिप का फाइनल चल रहा है बीएमसीसी का आ रहा हूँ Okay, guys. So
Hey everyone, welcome back to the channel. I hope you
in next video we will be continuing solving this